Hello, this is John in Skegness. I'm going to show you this time how to use a File Analyser to decode Meteor scatter and show you where it all is, assuming you've recorded some, that is. So if you use your FDM-S2 to record a duration of part of the FM band, I've recorded an hour's worth of material in this case, then you use this software, File Analyser, which is part of the SDR radio suite. You can get it from the version 2 release menu here. You can download from either of these sites here. I don't think you can download File Analyser from the version 3 page, but I could be wrong. And here it is. Click on Edit, not Open. Click on Edit and then Select and go to the directory where your files are. You'll only see one file, that's the header file, it's 000.wav. If you want to see all of them, drop down menu here, click on .wav, and there are all 60 files that I've recorded in this session. Each of these files is about a minute long. That's just the duration I've got each file set to record for. So just the first file, that's the one you want, open that. In this little area here, you'll see the duration. As you can see, 1409 to 1511. It's just over an hour, actually. So sometimes you might just see a minute or two in this session, or a much smaller period than what you've actually recorded. Sometimes you'll get this little glitch, and that's where you then go into the drop-down menu here and select individual files. So you might, let's say, only get the first few files and then there's a break, so you'll just have to do those and then go to the next one. And well, I hope that makes sense, but this can be broken sometimes, but in this case luckily I've got the whole duration. This is the next thing you need to select, height in pixels. Well, I've chosen 60,000. I think of this in terms of minutes. 60 is 60 minutes. That's roughly a 60-minute recording. That's the one you want. That determines the height, or the overall size of the waterfall, which in this case is 101 megabytes. So it's a big file and it's a waterfall. Click Analyze and the waterfall will be generated. And you'll see it goes very slowly. So it's looking at a group of frequencies there. And you can see the signals on the waterfall, and the time, well, it's going to take about 20 minutes to do. I'm running an i7 computer here with 8 gigs of RAM. You'll be running something different, so you might find this is faster or slower, depending on the speed of your computer. But in this case, 22 minutes it looked like at the moment. So time to put the kettle on. So I'll see you in the next session. Well, right, here we go, session 2. I've saved the file actually because that does take a long time to generate, and you can save these things as an XML file and then open them again as I'm doing now. So it's a case of here's one I did earlier, just as in the Blue Peter tradition. This is the waterfall. Right click and select Show Values, and you can see there you've got the frequency displayed. Power, that's just the strength of the signal, and the time. And oh look, there is a meteor burst, that little blob there. Well, let's go down to the bottom of the waterfall and start scrolling up. This is the beginning of the recorded period, 1409. Let's go up the waterfall until we see some blobs. And blobs are meteor bursts, and some of them much weaker than others, of course. If you look at this one here, that won't produce RDS, and that's what we want. We want the signals to be strong enough to produce RDS. So well, maybe that one will be. So that's 102.8 megahertz at 1412. So if we go to the Elad software, open that particular file, 1512. This is recorded in BST, but it's actually 1412 UTC or GMT or whatever. So that's the file. We press play. So we go to that time. There it is. Let's create a loop. And there it is. And that's the meteor burst there, as you can see. That's 10. Frequency is different. Right, this demonstrates another little glitch which I've been getting lately. I don't know why this happens. There's nothing I can do about it. The frequency readout on here is different to what it should be. At least it gives the time when the meteor burst occurred. So that's 14:12 and 5 seconds I've got there. And that is actually 105.5, not 102.8. But there it is, that's Romania, EE03, whatever the station is, I can't remember offhand, but there it is, meteor burst, and let's try the other ones. Another Romanian there. Maybe the same transmitter. Just try this one now. Alright, that one's not strong enough to produce RDS, but by playing that file over and over again a few times, you might just find that it will produce a PI code or something. So you can sometimes squeeze a P out of, pardon, yes, I did say that. You can sometimes squeeze a PI out of the file by repeating that little section. So like this. Sometimes it works, sometimes it doesn't. So there you have it. That's Meteor Scatter using FDM-S2 software and File Analyser. And as you go through the time on the waterfall, you can see various signals come and go. These look like aircraft scatter. Ah, nice long burst there. That should produce something. 15:03 and 45 seconds. 15:03, 45 seconds. 15:03. So 16:03 in other words. But let's try this. 45. Next file. 45 seconds. Here we go. There we go, Poland. Let's try that one. Okay, that one's not quite strong enough. But there we are, Meteor Scatter on the FDM-S2 using File Analyser software. That's it. Have fun.